Section 9.4, rational expressions. Our objectives are to simplify rational expressions and to multiply and divide rational expressions. So just to remember, or to remind you, a rational number is a number that can be written as a fraction or has a repeating or terminating decimal. So a rational expression in this case is going to be in the form of p of x divided by q of x, where p of x and q of x are a polynomial equation. So now we're simplifying a polynomial divided by a polynomial or multiply. So rational expression is in simplest form when its numerator and denominator are polynomials with no common divisors, and we'll talk about that. A rational expression is undefined for the values that make the denominator 0, because remember, we can't divide by 0. So that's why, and we'll talk about that in class, actually. We won't get that to that right now. And also, to simplify a rational expression, we factor the numerator and denominator completely, and then you divide out your common factors. So let's talk about some things that we remember from Algebra 1. Now, if I want to multiply a fraction by a fraction, so let's say we had 2/3, and I'm going to multiply it by 1/7. Remember, when you're multiplying, you would multiply your numerator times your numerator and denominator times denominator. So in this case, we have 2 times 1, which is 2, over 7 times 3, which is 21. And that does not simplify at all because we don't have any common factors between our numerator and our denominator. So that would be my solution. Let's say instead we had the problem 2/3 divided by 1/7. So remember, when you're dividing by a fraction, in order to solve this, you want to multiply by the reciprocal of the second number. So we have 2/3 times, and then this would get changed to 7/1, and then again, 2 times 7 gives me 14, and 3 times 1 would be 3. No common factors, so that would be my solution. Let's say instead we had something that did have a common factor. So instead, let's say we had 2/3 times 1/2. If this was the case, notice that we have a 2 right here in our numerator and a 2 in our denominator. Since they're being multiplied, we can cancel out those terms, and this would be equal to 1/3. Or if you look at it, before we cancel out those terms, you would have had 2 in your numerator, because 2 times 1 is 2, and 3 times 2 is 6, which reduces into 1/3. So that's what I'm talking about, canceling out something from your numerator and your denominator, because you have 1 in each. And so then that gives us 1/3. Now, when we're doing these rational expressions, it's going to be the same concept. When we're multiplying, you multiply numerator times numerator, denominator times denominator. When you're dividing a fraction by a fraction, you're going to want to multiply by the reciprocal of what's being divided. And the problem with these is that we're going to be working with polynomial equations, not just numbers, so you have to know how to factor these like we learned in the last section. Now, before we get there, let's also look at if, let's say, we had instead 2/3 plus 1/2. Now, notice that this is completely different than multiplication or division, because remember, in order to add two things that are fractions, we have to have a common denominator. Right now, we do not have a common denominator because we have 3 and 2, so what's common between 3 and 2 we know would be 6. So we would multiply this by 2/2, and then this would get multiplied by 3/3. And then when you rewrite your equation, you would end up with 4/6 plus 3/6. And then remember, when you're adding and subtracting fractions, you add the numerator. So 4 plus 3 gives me 7 all over your common denominator. So notice this is completely different than the multiplication and division. You can't cancel out common factors. Like, I cannot cancel out this 2 with this 2 because we are adding these terms. We're not multiplying or dividing. So I just wanted to show you that so that you don't get confused when we do those problems later. So I'm actually going to erase this. And I'm going to write a little note that you guys should also write down. And the note's going to be that you can only cancel out terms. So you can only cancel terms from the numerator and denominator when you are dividing or multiplying. So again, remember, it does not work for addition and subtraction, but we're not going to be doing that right now. We're just going to focus on multiplication or division. So let's go ahead and take a look at this first one. So for number one, we have a polynomial divided by a polynomial, and we're multiplying the two. So in this case, remember, you want to look for a common factor. So you could do a couple of things. You could just go ahead and multiply everything through right away. So 45 times 5 would give me 225. And then we have b squared in my numerator, all divided by 10 times 9 would give me 90. And then a to the third over b. And then remember, here we have 225 divided by 90. You could do that in your calculator. Hit the math fraction key. When you do so, you get 5/2. And then remember, when you are dividing something with the same base, you subtract the exponents. So the a's would be a to the first minus 3, which gives me a to the negative 2. Since it's negative, it means it goes in my denominator, so this would be a squared. And then same thing with the b's. We have b2 minus 1, which gives me b to the first, so that stays in my numerator. And so this would be my simplified solution. So that's one way to do the problem. So I'm going to erase this right here to show you the other way. The other way is if you wanted to simplify the terms as you were going. So I know that 9 goes into 9 and 45, so I could cancel these terms out. So 9 goes into 9 once, and I know that 9 goes into 45 5 times. And then I also know that 5 goes into 10 and 5. So 5 goes into 5 once, and 5 goes into 10 twice, and then cancel it out. So now I'd be left with, in my numerator, 5ab squared over b times a to the third. So it's kind of like what I had before, but instead of multiplying it through, I'm simplifying as I'm going. So that's usually how we're going to simplify a polynomial divided by a polynomial. And then when you simplify, you'd end up with this, just like we did a minute ago. So let's go ahead and look at number 2. So number 2, again, same thing. We have a polynomial divided by a polynomial. And notice that it's just being divided by one term. There's no addition or subtraction signs in between. So that means that I can use my properties of exponents. So we have negative 3 to the third power times x. And remember, you're multiplying these exponents when you're doing this. So x to the 6th, y to the third, divided by 9x squared, y squared. Negative 3 to the third power would be negative 27 over 9, and then we have x to the 6th, y to the third, x squared, y squared. Negative 27 over 9, I know it's going to reduce into negative 3. So we have negative 3. And then we have x to the 6th, I'm doing some work off to the side, minus 7, which gives me x to the negative 1 power, so that means that, or no, that's a 2, sorry. So x 6 minus 2 would give me x to the 4th power, so that stays in my numerator, so this would be x to the 4th. And y to the third over y squared would be 3 minus 2, which would be y to the first, which would also stay in the numerator. So then this right here would be our simplified solution. So now let's do some harder problems with what we learned before. So let's look at number 3. So number 3, we have a polynomial divided by a polynomial, and we're dividing two fractions. So in this case, because of this division right here, remember that means we're going to want to multiply by the reciprocal of that second fraction. Before I do that, though, I want to factor these equations because I have 3 terms in my numerator and denominator. That's the only way that we're going to be able to simplify this. So why don't you take a second to pause the video to see if you can factor all of these trinomials that we have for each the numerator and denominator, and then come back. So when you simplify this one, and by factoring, in the first equation you would have had 2x plus 3 times x plus 1 divided by, and the denominator factors into x plus 7 times x plus 2. So for the first one, you had to do the Swedish fish, or slide and divide, and the second part, factors of 14 that add up to 9. And then we're dividing that by, and I factored this as well. So this factors into, and again, you'd have to do slide and divide method, 2x plus 3 times x minus 3. And in my denominator, factors of 7 that add up to 6. I know I have my parentheses, so I would have x here, and then your signs, you know, would have to be opposite, because a negative times a positive would give you a negative number, and we want the bigger number to be positive, so this would be 7 and 1. Now, in order to do this, before we can cancel out terms between our numerator and denominator, since this is division, we want to first change that into multiplication by flipping my numerator and denominator for that second fraction that I have. So I'm going to rewrite this over here. We have 2x plus 3 times x plus 1 divided by x plus 7 times x plus 2 multiplied by x plus 7, x minus 1 divided by 2x plus 3 times x minus 3. So notice what I did was I just changed this into my denominator and I put this into my numerator. Now that I did that, just like I did when I had my numbers up here, notice that we can cancel out common terms between your numerator and denominator since this is all multiplication and division. Now, and when I say that, I mean each binomial is being multiplied by the other binomial. Yes, we have additions of signs in our equation, but this whole term is being multiplied by this term, and so on and so forth. So I want to look for common terms. So notice I have 2x plus 3 here being multiplied, and 2x plus 3 here being multiplied. So since those are common, and you have 1 in your numerator and denominator, that means you can cancel out this term and this term. So let's keep going. So then I would look for x plus 1 in my denominator, which I don't have any. So now I'm going to go to my x plus 7 here. So we have x plus 7 here and here. So since those are common, those are going to cancel out. And then I'm going to look for x minus 1, which I don't have. So there are no other common factors. So when I go ahead and write this next part, numerator times numerator, so I have x plus 1 times x minus 1 divided by x plus 2 times x minus 3. And then this right here is going to be my solution for now. Now technically we would have to multiply those out, but I want you guys just to leave it in factored form now, because simplified would mean that we wouldn't want any parentheses in our equation and you would combine like terms, but I want to see your factor so you can leave it like this. So let's go ahead and do number 4. So for problem number 4, this one's a little bit harder. So if you look here, this is the big division symbol, and this is being divided by this term right here. So we have w squared plus 2w plus 1 being divided by w plus 1 over 3. So what I would do is I would rewrite this first, and I'm going to factor the w squared plus 2w plus 1. So I want factors of 1 that add up to 2, which would be w plus 1 times w plus 1. And this is being divided by w plus 1 over 3. And usually this division sign is bigger or thicker than the 1 to tell you that that's the two terms that are separated. So remember, if I have a term that's being divided by another fraction, we want to multiply by the reciprocal of that second term. So this right here is really over 1 if that helps you to write in, but it's not necessary if you don't need to. So I'm going to go ahead and rewrite this. I have w plus 1 times w plus 1 over 1 times, now I'm going to flip that, so 3 over w plus 1. Then remember, I look for common terms between my numerator and denominator. I have w plus 1 here and here, which are common. Since this is multiplication, we're allowed to do that. So in my numerator, I have w plus 1 times 3 all over 1, and I don't need to really write that over 1, so then this would be my solution. Okay, let's do one more. Let's do number 5 and then we'll finish the rest in class. So number 5, notice that this is a little bit thicker right here, so that tells me that this is in my numerator and this is in my denominator here. So I have, again, a fraction divided by a fraction. So that really means I have 5a squared minus 20 over 2a plus 2. This is being divided by 10a minus 20 over 4a. So the next thing I'd want to do is I want to go ahead and factor this, which I'm going to do underneath. So I know for the first part, look here, you have a greatest common factor, which is what you always look for first. So that means I know I can factor out of 5. If I factor out that 5, I get 5 times a squared minus 4. And inside my binomial, I have 2 terms, and it's the difference of squares, so I can factor that further. So I have 5 times a minus 2 times a plus 2 over, and in my denominator I can factor out my greatest common factor, which is 2, and that would be a plus 1, being divided by, here I also in my numerator have a greatest common factor, which is 10, so I'm going to factor that out first. So when I factor that out, I get 10 times a minus 2 over 4a. Now remember, I don't want to leave my equation like this. I want to flip my second term because it's division. We want to change it into multiplication, so I'm going to do that up here. So I'm going to rewrite it 5 times a minus 2 times a plus 2 divided by 2 times a plus 1, and then multiplied by 4a over 10 times a minus 2. So now I want to look for common factors between my numerator and denominator that I can cancel out. So a minus 2 and a minus 2 would be gone. And then I notice that I have a 2 and a 4. So 2 goes into 2 once, and 2 goes into 4 2 times. I also have a 5 and a 10, so I know 5 goes into 5 once, and 5 goes into 10 twice. And that means that I have 2 over 2 again right here. So this would be gone because 2 divided by 2 is just 1. Or if you wanted to, you could multiply the numerator times numerator, denominator times denominator, and then simplify. It doesn't really matter. So right now I have 1 times a plus 2 times 1a. So that's just a plus 2 and then times a, my numerator. So we're doing this step down here, so we're taking this whole thing. And then I have in my denominator 1 times 1 plus a here for this first fraction, and then times 1 again, so that just would be a plus 1. And then for right now, we're going to leave it in factored form, so that would be my solution. So the next thing we'll talk about, we're going to do problem, I would want you guys to try to see if you can do problem 6 on your own, and then we'll look at it in class together. And then also, we're going to talk about looking for restrictions, and we'll talk about what a restriction means on during class. And remember, restrictions are going to be things that make your denominator 0. So things that make our denominator 0s are numbers that we cannot have. And again, we'll talk about that. So do number 6 and then bring this with you to class.